Imagine dropping a giant steel ship into the ocean. Not a toy ship, a real one. One weighing hundreds of thousands of tons. Logic says it should sink immediately. After all, steel sinks. Everyone knows that. So why doesn't the ship? Why can a massive floating city stay on the surface, while a tiny steel nail falls straight to the bottom? That question puzzled people for centuries, and the answer reveals one of the strangest laws in all of physics. Stay with me, because in the next few minutes, you'll discover the invisible force that keeps entire cities floating at sea. And if you enjoy uncovering the hidden science behind everyday things, subscribe to Curious Corner, because the world is stranger than it looks. Every year, giant cargo ships carry over 90% of global trade. Some are longer than skyscrapers are tall. Some weigh more than entire towns. Yet they float effortlessly. Meanwhile, a small rock sinks in seconds. At first glance, it makes absolutely no sense. But hidden beneath every floating object is an invisible force. A force powerful enough to lift entire ships. Most people think floating depends on weight. It doesn't, at least not in the way you think. Take a bowling ball. Drop it into water and it sinks. Now take an empty plastic bottle. It floats. The bottle may be lighter, but weight alone isn't the reason. The real secret is something called density. Density measures how much mass is packed into a certain amount of space. Some objects are tightly packed. Others contain lots of empty space. And water is constantly comparing its own density to whatever enters it. That's where things get interesting. The moment something enters water, the water pushes back from every direction. But here's the strange part. The pressure beneath an object is slightly greater than the pressure above it. That difference creates an upward force. Scientists call it buoyancy, and buoyancy is constantly fighting gravity. Gravity pulls down. Buoyancy pushes up. The winner decides whether something floats or sinks. Now let's return to the steel ship. Yes, steel is denser than water. If you throw a block of steel into the ocean, it sinks. But ships aren't solid blocks. Most of a ship is empty space. Huge rooms, cargo holds, hallways, storage areas, air, lots of air. When you combine all that empty space with the steel structure, the ship's average density becomes lower than the water it displaces. And that's the secret. A ship floats because it pushes aside enough water to create a buoyant force equal to its weight. The bigger the ship gets, the more water it can displace, and the more support it receives. More than 2,000 years ago, a Greek mathematician named Archimedes was asked a strange question. How could someone tell whether a crown was made of pure gold? While thinking about the problem, he stepped into a bath and noticed water spilling over the edge. Suddenly, he realized something important. The amount of water displaced revealed information about the object inside it. Legend says he became so excited, he ran through the streets shouting, "Eureka!" meaning, "I found it." That observation eventually became one of the most important principles in physics, and every ship floating today still depends on it. If ships are designed to float, why do they sometimes sink? Because buoyancy only works if enough water stays outside the ship. When water enters the vessel, the average density increases. The ship becomes heavier, and eventually, gravity wins. That's exactly what happened to many famous shipwrecks throughout history. Not because the ocean stopped pushing upward, but because the balance between buoyancy and gravity was lost. The next time you see a ship crossing the ocean, remember, it isn't floating because steel suddenly became lighter. It isn't floating because the ocean is gentle. It's floating because millions of tons of water are pushing upward every second. An invisible battle between gravity and buoyancy. A battle so powerful, it can hold entire cities above the sea. And once you understand that, you'll never look at a ship the same way again. Subscribe to Curious Corner, because sometimes the most ordinary things hide the most fascinating secrets.